Alright, so we're given that the integral from 0 to 2 of f of x equals 4, the integral from 2 to 5 of f of x equals 12, the integral from 0 to 2, g of x equals negative 3, and from 0 to 4, g of x equals 6. We have to evaluate this. So basically, a, b, and then c, d, and e are going to equal some particular number, okay? We don't have specific functions just yet, but we do know that f of x from 0 to 2 equals 4. The area underneath that curve is equal to 4. And so we can use this information to help us actually evaluate a. So from 0 to 2 of 3f of x minus g of x dx. Since this is a minus here, we can do that sum difference one that says from, let me change the color, that says from a to b, or in this case 0 to 2, 3f of x, I can subtract it from 0 to 2 of g of x dx. Okay? Now for this first part, I got a constant, right? What do I do to the constant? I take it out. So then this becomes 3 from 0 to 2 of f of x dx minus 0 to 2 g of x dx. And I'm just showing all the steps. You don't, I mean, if you already know it, you can of course skip this, but I'm just showing all the steps. Now, from 0 to 2 of f of x dx, what does that equal? Say again? 4. It equals 4. Because it was right here, it was given to you. So that means I can replace this entire part with a 4. So this becomes 3 times 4 minus, what is that value? Negative 3. It gives it to you right here. So from 0 to 2 of g of x dx, that equals negative 3. 2 negatives make a positive. And what is this answer? 15. Okay? Bless you. So for this integral from 0 to 2 of 3f of x minus g of x dx, the area is 15. Do you see how it works? It's not specific functions just yet, but it gives you all the information that you need. Let's look at b. We have the integral from 2 to 2 of g of x dx. What is that going to equal? 0. This was property number 5. Remember, if it has the same bounds, in this case 2 to 2, no matter what, the area is always going to be 0. Plus, this says 5 to 2 of f of x.
So would that be 2 to 5, and then you can flip it?
I surely can flip it and say it's from 2 to 5 of f of x, but what happens when I flip it?
Negative.
It becomes negative. So from 2 to 5 of f of x dx, that's going to be a negative 12. And there's your area. Okay? So whatever these functions are, whatever f is, whatever g is, the area from these particular intervals are these values. Okay? Question before we move on to the next ones. Yes?
Would they ever like put numbers in there instead of the functions, like the actual function?
Yes, but that's actually, if they just put a number like a constant, that's actually going to the case that we're going to be talking about on Monday.
Okay.
And so it deals with something different. But yes, they very much can. Okay? So give me a second to write down C and D. It's the same problem, but here's C and D. And I'm going to put E. So let's look at C. This says the integral from 0 to 5 of f of x. But I don't have a 0 to 5 f of x in my original problem. Jacob?
Could you just do 0 to 2 plus 2 to 5?
Exactly. This can be rewritten as from 0 to 2 of f of x dx plus from 2 to 5 f of x dx. I very much can do that. Okay? And it'll still give me my area from 0 to 5. So what is the first part? 4. And the second part? So what's 4 plus 12? 16. Okay? So basically, it's asking us whatever our function is, okay? Whatever function is. I'm just gonna make up a function. We don't know what f of x is. But basically, it's asking us to find the area from 0 to 5. It's asking us to find this. Now, the truth of the matter is they didn't give us what that value was. But what they did give us was that from 0 to 2, this area is 4. And then from 2 to 5, this area is 12. So we can actually find from 0 to 5 by just adding the two together. That's how that works. Okay? Let's do E first before we do D, because D probably might throw you off a little bit. Look at E. It's from 2 to 4 of g of x dx. Do I have a 2 to 4? No, so what do you think I can do to get that area? I can subtract from 0 to 2 from the 0 to 4. Very good, okay? Same type of concept, right? 1, 2, 3, 4. It's asking, whatever the curve is, it's asking us to find the area from here to here. Truth is, I don't have that. I can, is that 2 to 4? That is 2 to 4. I have the whole area from 0 to 4, and then I have this little area right here. So I can easily take the whole thing, subtract it from that little piece. Yes?
Do you have an area to 4? I thought we only had 5.
For f of x, we have it to 5, but for g,
Oh, for you, that's
we got it to 4. Yeah, see, that's how they can throw you off too. And give you two different functions, you gotta make sure you use the right one. So this one can be written as from 0 to 4, g of x dx, minus 0 to 2, g of x dx. It's kind of like I got the whole thing, I got the part I don't need, so I can subtract and find the part I do need. So what's from 0 to 4, g of x, what is that? 6. And now I can subtract that from negative 3, which makes it a positive, so I get 9. How is this? Hopefully D won't throw you off. Alright. So D's a little bit different. Why?
because we don't have those measurements.
We don't have these numbers, that's one, and then on top of that, we got a plus 3 in here. Okay? We got a plus 3 in here. Now when that happens, don't let it throw you off, okay? We can actually tackle this very easy. First off, what can I do to that 1/2? I can take it out. So I have 1/2 from negative 3 to negative 1 of f of x plus 3 dx. Now this plus 3 just basically means that, I've moved along the x-axis. So I can actually add 3 to both of these values to compensate for the fact that I just literally moved my function over. I didn't change the function, I just literally moved it over. So if I just add 3 to my bounds, it basically moves it back to a spot where I can actually find the area. So when this happens, since it's a plus 3, I add plus 3 to the lower bound and the upper bound. So this becomes 1/2 of 0 to of f of x dx. And don't we have that?
Yes.
What is it? 4. So this becomes, I'm out of space. I'm swinging up here. It becomes 1/2 of 4, which is just 2. Okay? So let me recap that one. We pulled out the 1/2 because it's a constant, so we used our constant rule. And because there was that plus 3 on the inside with the x, that literally just meant that the function got moved over 3 units. So to compensate that, we're going to move it back. To do that, we just add 3 to both the upper and lower bound.
Because the area doesn't change.
Exactly, because the area doesn't change when you move it. Questions?